I think WWDC would start being called Why Was Design Changed?
I really want Apple to focus on having a good platform, right? The mobile devices, the iPad, the Macs, all coming together. And I actually think that's the bigger story of WWDC.
So I think Meta is really betting on securing its foundational AI supply chain with this acquisition, which I think is very strategic and it's the right move for them. Infrastructure matters as much as models. Training, data, evaluation, human feedback. And I think this is where the AI wars are being fought right now.
Tim gives us homework every time we appear. It's like, you need to read the Apple Intelligence one. You need to read Sam Altman's blog post. And you're like, okay, I'm going to stick it through O3 Pro. I might as well test that out. 13 minutes later for it to read the paper. You're like, come on, dude, I could have read that myself.
You're saying like quantum's like already here is kind of what you're saying.
We're saying you're probably going to show quantum advantage, so doing something better, faster, cheaper than a classical computer by 2026. And actually, I think it's going to be even sooner than that.
All that and more on Mixture of Experts, a Think podcast. I'm Tim Huang, and welcome to Mixture of Experts. Each week, MOE brings together the sharpest team of researchers, engineers, and product leaders that you'll find anywhere in podcasting to discuss and debate the biggest news in artificial intelligence. Today, I'm joined by a rock star cast: Chris Hay, Distinguished Engineer and CTO of Customer Transformation; Shobit Varshney, who is Head of Data and AI for the Americas; and Kautar El-Maghraoui, Principal Research Scientist and Manager for Hybrid AI Cloud. As always, we have a ton to talk about. We're going to talk about a bunch of news out of OpenAI, a huge deal for Scale AI, and you should stay tuned for the end, where we're going to have a special segment that's going to focus specifically on a very interesting announcement that just came out about quantum. Before we get to all that, I want to talk about, obviously, Apple's WWDC, which is their annual developer conference, the big kind of showcase for what Apple is going to do. And there were a bunch of announcements that kind of came out. But first, I want to just go around the horn and get everybody's opinion on, what coming out of like the keynote, I'd say, are we going to still be talking about in 6 months? Shobit, I'm curious what you think.
I think WWDC would start being called Why Was Design Changed? I think this may end up being a Windows Vista moment. But I just have been, I've been rocking the Neo Gloss OS for a while now, and it's just not quite ready yet. And I am very confused when the Gloss design is not quite ready. They're comfortable shipping that, but they're saying that they can't ship AI because AI is not quite ready. So they have to pick a lane.
Yeah, for sure. Kautar, what's your reflection? Anything that we're going to be remembering this WWDC for?
I think the still highly competitive pressure from OpenAI, Meta, Google, Samsung, especially kind of emphasizing Apple's late AI entry, it puts us under a lot of pressure. And questions around, did Apple's partnership with OpenAI evolve or backfire? How does Apple AI stack, compare to what Meta and Google are doing with their, Llama, Gemini, and so on? So, and especially another, I think point of concern is the and disappointment for many. It's, the overhaul around Siri, and the AI advancements, that they're claiming here, which seems to be kind of still lagging behind, the competition out there. So
Yeah.
I also agree with Shobit around the liquid glass interface. I think it's a
Let's
change
get a final
everyone
dig in there
will
on their
encounter
UX
daily.
UI.
Is that, really making its, reception and any potential flaws more, I think, immediately apparent and maybe even more controversial here.
Yeah, for sure. And last but not least, Chris, what did you think of the show?
Even darker dark mode. In fact, I didn't realize how undark my dark mode was. And then I was like, oh, I can get dark mode even darker. That's what I want. So I thank you, Apple, because I love my dark mode, and the even newer, even dark mode is gonna be awesome. So I'm excited about
Comes
that.
as welcome news.
Yeah.
Yeah.
But on a more serious note, I actually think that the ability to access LLMs on device is going to be huge as part of the framework. And I think because otherwise there would have been a risk of loads of apps trying to install small models onto your phone, etc. And I know some people have been doing that already. So actually just ubiquitizing access to on-device LLMs and being able to easily hook that into your own applications. We can argue about how good the AI on those devices are, but the fact is Apple does have the best hardware. Apple Silicon is incredible. So I'm excited to see new and interesting applications via these SDKs. And I think that's a little bit of a glimpse into the future because I think we're a little bit too low level at the moment, and Apple's going to lead a little bit of that way on framework access.
Yeah, for sure. And actually, that's a great place to kind of pick up because I think that, I was looking at, say, the Verge coverage of WWDC, and there's like a long list of announcements, but in pretty stark contrast to where they were on the last WWDC. Like the AI stuff is actually weirdly kind of not as prominent or not as talked about. Certainly, people are complaining a lot more about the UI, UX designs. But if there's anything that Apple seems to be doing on the AI side, it's like opening up new surfaces for the AI to interact with, right? So it's one, any developer can go and play with their models. There's also kind of this new idea that like Apple Intelligence will be able to see what's on your screen and kind of interact with it, which I think is also pretty interesting. And so I guess, Shobit, maybe a question for you is like, Apple seems to almost be kind of admitting, look, we're not necessarily going to be a leader on the model game, but we might try to kind of use our unfair advantage in terms of like our ecosystem. Is that the right way of thinking about what they're trying to do here?
So I think it's their only play left, right? I mean, they had a lot of one-on-one sessions, post-event announcements with different YouTubers on explaining and rationalizing why they are missing out this year on AI. They went through two different architectures, and the first one it could do a lot of the stuff they wanted to announce, but it was not quite prime time ready for them to roll it out, right? So their only other choice at this point was to make sure that we do subtle things across the entire ecosystem, having having Apple Intelligence move away from becoming the oxymoron of the year to actually starting to deliver some value. I think that is the future direction that they have to take, and they need to come to a point where if they if they either champion the small models running on device, and hence they can tout a lot of security and stuff like that. In the current phase, the Google Gemini, the Gemma models, the 3 billion parameters that run on device, 4 billion parameters, those are actually pretty good right now, and they're actually better than what Apple just released. So Google is still ahead on the game, even on device. It seemed like a lot of the stuff that they were announcing were catching up. I was like, "Ooh, I can change the wallpaper in my iMessages like WhatsApp did like a decade back," or stuff like that. Has to like they have to get away from these small incremental changes to something that adds some real intelligence. There are very few companies where I would trust all of my personal data with, and Apple has definitely won that trust from me, right? So I'm very comfortable with my kids having access to an Apple phone, the parental security guardrails and stuff like that. They've done a really good job around it, right? So when we have, as a family, trusted Apple with so much trust, they have all the data, and I would rather have them deliver personalized experiences to me versus some of the competitors, right? It'll be a nightmare for me to even think about, say, DeepSeek or some of the other competitors to have access to all of my data. So we have made our choices: email, Gmail, right? I'm okay with Google having images of my passport and my medical records. All of that goes through my emails and stuff, right? Both Google and Apple have an extraordinary opportunity to hyper personalize intelligence that OpenAI or AWS and stuff just cannot get close to. But I think Apple in this case has to really double down. They could not have afforded a gap year in AI, and that's exactly what they're doing right now. If I was in that, like, heads should roll on these kind of announcements.
Yeah, for sure. Kautar, I think kind of one of the most interesting parts of this discussion, and I think the last time we really talked about Apple was the daring fireball kind of Gruber takedown of Apple. And I think the narrative through all of this is like, it's almost like what Google was maybe 6 to 12 months ago, where everybody was like, how can you not be winning in this space? Chris just talked about this like incredible hardware they have access to. Shobit just mentioned all the incredible trusts they have access to. What's your diagnosis of Apple? Like, what's going wrong? Like, by all rights, they should be crushing it. But curious from your vantage point, like how you diagnose the issue.
Yeah, I agree. I'm also like a bit disappointed in terms of this underwhelming AI progress. Um, so for Siri, I think they delayed their Siri overhaul, which is I think a big significant point of disappointment. I see that across many reactions online. They had promised a much smarter, more versatile Siri, but comments, it's not ready. I think they're trying to be very cautious, or maybe very kind of conservative in their approach. Is it because they're worried about, they want this privacy first approach where they're trying to be really careful and they don't want to kind of mess up things with the AI and the privacy aspects that they take so hard, so in heart, like Shobi mentioned. So I also trust their platform. I love all the integration they have, the control that they have over the entire stack, all the way, from the apps all the way down to the silicon. It's a very strong position that they have. But I feel they're overly cautious here in terms of their AI strategy. And especially with all the hype happening, elsewhere, what's holding them back? I also don't understand, what's going on here, why they're taking a very conservative approach. And especially if you look also at the paper, I think we're going to talk about it, maybe the paper that they released, it was also timely, maybe the timing of the paper right before the WWDC, where they had all of these skepticisms and so on about AI. Um, Kind maybe to justify why they're very kind of incremental and cautious and taking a slow move. In the WWDC, they focus on a lot of other things other than AI. They say, okay, there is AI, but there's all this other stuff like productivity and visualization and integration and the liquid glass, a lot of focus on that, like all other stuff that I think they're positioning also as important, which is important. But AI is also kind going so strong elsewhere, and we need a strong position from Apple on this.
So this might have been just regrettable timing. Who knows, right? But basically, Apple also released a paper that got a lot of chatter this same week entitled "The Illusion of Thinking." And in some ways, it's kind of a critique of what reasoning models are doing. And I think the narrative online, at least, was, well, it's weird that these researchers don't even have confidence in the technology they're pushing. I don't know, Chris, like how you're going to respond, but I think there is a question of just like, does the company culture even really believe in the technology that they're pushing here?
I like Apple's approach to this, and I have to say we are in a hype cycle just now, and I know we'll get to the paper a little bit later, but I really want Apple to focus on having a good platform, right? The mobile devices, the iPad, the Macs, all coming together, and I actually think that's the bigger story of WWDC, right? Which is that they've unified it, at least on the numbering system for the operating system, right? But actually, I think they are trying to make this a stack where I can
Hmm.
easily go from one device to another, and they have control of the full vertical device and the platform, and they all connect. And we can mock the liquid glass, but actually, they've done a very clever thing here, which is they've built a design system that allows you to be able to have consistency regardless of the form factor. Now, that's going to be important in the future because actually we are going to want to switch from our iPhone to our iPad to our Mac and not feel as if we're on a different operating system. So I weirdly think they're setting themselves up for the future at a platform level. And I also think they're setting themselves up from an AI perspective because they're focusing on the SDKs, the hooks, and how people are going to hook into that. Yes, their AI clearly is not matching up to the ecosystem and the platform that they're building, but they'll catch up on that. So I would rather they fix all of these things anyway and prepare for the future. And then we're going to have great developer experiences. I don't feel as if I'm missing any AI stuff on my phone. If I need to go and speak to an LLM, I'll just bring up the Chat GPT app. It's fine, right? So I'm okay with the approach that they're taking. But full disclosure, I'm a full on Apple fanboy, so it's fine.
So, so Chris, I'll summarize what you just said. iPad is more like Mac. Mac is now more like iPhone, and iPhone is more like Android. Is that fair?
No, I am not. I'm not taking your Google centric view on this show, but with your love for Gemini. And if you ask Gemini to code, then you might as well get a 3-year-old bashing at a typewriter because you're going to get equivalent code coming out of it. And I get that you love Gemma and that fact, and I do love Gemma as well. But the reality is, these smaller models, the Apple will catch up on that in time. So I just think there's two approaches. You can chase the AI part, and everybody is chasing that, and that's important. But actually, they're chasing their platform and trying to make that consistent. And I don't think that's a bad move.
So I think Windows has done a better job at opening up the Mac OS with more MCP based things that I can actually tap into. So my apps that I'm building are actually being able to take actions. I was hoping that Apple will create an ecosystem where we can start to build apps on top of that. Again, we'll see what coming out of this. I think there's a huge potential that we can do there. Second, my challenge right now is if I use a different app, say ChatGPT on my phone, ChatGPT does not have the rich data about me. I don't want ChatGPT to follow me and track my location, preferences, and emails and all of that quite yet. So instead of replicating the trust I built in Apple or Gmails with Google and stuff, or Google Photos, I don't want a third party app to give me a service that's not hyper personalized to my needs. There's a huge missed opportunity by Apple. Hopefully next year.
Yeah, hopefully. And I think also, even, I think in their image, playground, for example, uh, the features like the photorealistic image generation or these advanced generative features, I think it would be nice, for them to have that. Uh, and of course, on the Siri, I agree with you, Shobit, because of, their hand on the data, the customization is going to be a big leap, if you can integrate that all together with their Apple AI intelligence, with more advanced conversational capabilities and generative AI features. But hopefully, I think they're delaying because they want to get it right. So that's, I think, what I'm thinking why it's taking. But I think Chris's point on the getting the platform right is also a very important one.
Yeah. Well, we'll have to wait and see. There's more coming. And I mean, I think with Apple, they can just keep taking more and more shots on goal, right? I think that is one thing that people frequently miss is they can get it wrong for a very long time before they get it right and still largely be okay. All right, I'm going to move us on to our next segment. Some interesting news coming out of OpenAI this week, both of a product nature and also of a philosophical nature, I suppose. And I kind of want to talk about both stories together. So, one announcement, not unexpected, is OpenAI announcing the availability of O3 Pro, which is basically the more advanced version of their reasoning model that has kind of taken the world by storm, and also some kind of pricing updates there about how cheaply they're able to offer a lot of their existing models. And then secondly, Sam Altman published this sort of essay called The Gentle Singularity, where he kind of like makes the argument that we're already living through the singularity. It's not a future thing, it's happening right now. And, the world is going to feel like very different over the next decade. And maybe, Kautar, maybe I'll throw it to you first is, when you play with the O3 and O3 Pro, like, I guess I kind of want to ask the question, like, do you agree with Sam Altman that we're like already living in the singularity? Like, basically, that like it's wild that we have technologies that can do what O3 Pro can do. How do you kind of think about that? But like, I think that's one reflection is like how much we buy what Sam is telling us.
Yeah, very, very good question here. I think, of course, the O3 model has brought a lot of advanced features, especially on the reasoning capabilities, the multimodalities. I think really nice features there, especially focusing on the reasoning aspects. But I think if you look at, Sam's paper, the essay, what I think is it's a bit, kind of optimistic. He's over optimistic. He's, softening the idea, of this runaway AGI. He's saying that this won't be a Terminator. It'll be an assistant helping you solve hard problems. This super intelligent that's going to exceed our intelligence. So it's a smart narrative shift. I think it's more politically and socially acceptable than machines can take over. But I think maybe he's over optimistic. There are still a lot of challenges that we have to solve. And I think he's trying, especially to align with OpenAI vision. They're trying to deliver on the vision of the reasoning tools that help humans think. It could reshape science, economics, and education. But I think there are still a lot of issues around the misalignment, around the impact of these things, on jobs, around also kind of the equal access and democratizations of AI, because this might also kind of intensify the division globally, who gets access to these technologies and might privilege, certain people versus or certain nations versus others. So there are a lot of other issues. I think that's are much deeper than, I think the nice and utopic vision that Sam painted. So I feel, he's over optimistic, but there are a lot of issues that still needs to be resolved.
Right. You're almost like it's still ahead of us in some sense. Yeah. I mean, Shobit, thoughts? Like, I don't know if you've played with O3 Pro, any impressions?
So the first thing I did was look at Apple's paper that said, "Oh, these models can't think." They have the full prompt for the Tower of Hanoi problem, where you have to move the pegs over. I took the exact same thing, gave it to O3, it's slam dunk. Like it just crushed it right away. So within a few days, OpenAI just came and swinging. I was like, guys, stop making excuses. AI is working really, really well. And if you think about this from an enterprise perspective, for us, we are more, it doesn't matter that the world has somebody who won a Nobel Prize or somebody who's like Einstein level IQ and stuff like that, right? As an enterprise, it's very important for me. Can I take that capability and apply it to a particular system? Can I solve for a problem? Can I deliver economic output? And that requires us to have a hierarchy of intelligence. Generally, in our organizations, we have an obscenely overpaid CEO at the very top who's an expert in multiple areas. But by the time you get to the accounting department, the procurement department, HR, and so on and so forth, you have a really small model that went to a community college that has been doing accounting really well. And that's the right price point and the capability intelligence that we're expecting for that particular job role. So I don't think that O3 coming out with a brilliant model is something that's going to drastically change the narrative within the enterprises quite yet. We can deliver an insane amount of value with the existing intelligence that we already have, and it has to be more ROI driven intelligence versus O3 Pro being, it's quite expensive. But the fact that it just came and just rained over Apple's parade, on one side somebody's saying, hey, AI ain't quite ready yet, the other one is saying, hey, just come on, stop talking about like this is crushing through this very, very quickly, right? Two ends of spectrum of the same story.
That's right. And I think, Chris, I think what's so useful in the show, but I'm really glad you brought up that Apple paper again, because it kind of definitely looms large in my mind, right? Is basically like, it definitely offers a challenge to what we're seeing with the reasoning models. And I guess, I don't know, Chris, is what your take is like, is Apple just wrong in what they're arguing here, given everything that we're seeing out of OpenAI?
Well, I did exactly what Shobit did as well. I took the paper and gave it to O3. And because I was like, that's what I love about this show. Tim gives us homework every time we appear. It's like, you need to read the Apple Intelligence one. You need to read Sam Altman's blog post. And you're like, okay, I'm going to stick it through O3 Pro. I might as well test that out. 13 minutes later, 13 minutes later for it to read the paper. You're like, come on, dude, I could have read that myself. You know what I mean? So I love O3 Pro, but it takes a long time. Um, on the Apple paper, I think it is really interesting. Actually, if you ask O3 Pro about it, it's kind of like, yeah, the core of the paper is about right, but actually, they've only gone with a single prompting strategy, etc. Is that really going to pan out over time? So I think even the O3 Pro was a little bit skeptical of the paper. I think there is some relevant points though, which is that um, I think puzzle based approaches. So if you look at the Apple paper, they were talking about doing things like the Tower of Hanoi, etc. I think these puzzle based approaches are important because there is a lot of contamination within these models. They have seen things before, and therefore, how do you distinguish between regurgitation and true thinking in that sense? But the flip of that is, I mean, if you take, especially let's take code for example, and I'll go back to my favorite model, which is Claude 4 Opus and Claude 4 Sonnet, right? I mean, even without thinking, these models are able to just spit out, unique code, um, end to end, thousands of lines of code, and it's just perfect. Oh, okay, you're gonna have to change some stuff, etc. But it is incredible. So I think even if it's simulation and and they're saying that the reasoning isn't going that far. The reality is it is able to do the tasks that I want it to do to some extent. And I think maybe that's the thing to focus on. Is it providing value? And the answer is yes. Now, the other thing on that paper that I think is useful is they're saying is that um, the models sort of collapse in on itself, right? After it generates enough tokens, for example. So when it's sort of reasoning about something, after a while, it will sort of go in a bit of a spiral because it doesn't know the answer. And there is a bit of a fundamental flaw to this, which is it doesn't have access to things like tools in this case. So there's not a freshness of information coming in. So it's sort of going into a spiral. So I understand the paper and I get where they're going with this, and I get what they're saying about that actually if you take multiple samples you can get to, via the Pascal side of things, very similar to you get similar results to what you get from reasoning. But I think the reality is diversity of data in that case becomes more of a thing. So I'm somewhere in between on that paper.
Yeah, that's actually a really interesting response. And yeah, I think it's like, I mean, I'm just reviving a phrase that I don't think we barely use anymore nowadays, which is like, I think people used to be like, these are stochastic parrots, right? All they do is they copy. And I think like, I guess my response to this is kind of like, I don't know if debating what intelligence really is kind of is very helpful. Cause in some respect, it's like, okay, so say it is copying. It's like incredibly useful for all the tasks that I need and can have a huge impact even with that in mind. And then Qatar looks like you might want to kind of jump in, but I feel like that's kind of one of the interesting tensions that we have with this era of these language models is, yeah, I mean, they might just be copying in some respects, but it really feels pretty strongly like it's a kind of reasoning that solves problems. And I kind of can't get too fussed about it.
Yeah, and if you look at this paper, the illusion of thinking paper, you know, some of the things that I thought also the methodology that they also used, which they cherry picked these tasks. So for example, the logic of the puzzles that was chosen. Even I think humans struggle sometimes with these things. So does that represent the full spectrum of reasoning tasks? So and another thing, these artificial constraints, so things like so it did not, for example, in this paper, Apple did not allow the models to use coding as a tool to solve the problems. For humans and also for powerful AI models, writing code is a fundamental way to tackle complex logical problems. So these restrictions, restricting, this capability, could artificially also limit the model's performance and also misrepresent, kind of the true reasoning potential. Um, there were also things like the output, the token output limits that they had. Some tasks assigned reportedly, I think exceeded the model's token output limits. So, and essentially setting the models up for failure. And, it's kind of like a all or nothing grading thing, this strict, complete accuracy collapse, quote, quote, metric. I think it might be too harsh. So I think the approach, I feel there are some flaws, in the methodology that they used. And, also some of these exaggerated claims or misinterpretation of the reasoning. So, for example, the semantics of reasoning, are, so, some people, from the analysis I looked at, some people argue that, the paper's title and conclusions are kind of they could be looked as inflammatory and misrepresent, what really LLMs are actually doing, while they might not maybe reason in a human conscious way. Their ability to perform these complex calculations and generate coherent logic and use tools in a form of, a kind of reasoning form, even if it's based on pattern matching, it is also a type of reasoning. And hopefully that's going to evolve and improve over time.
So, Tim, I'm going to start a whole campaign around AI rights matter. Like we should not discriminate against AI. And the reason I say that,
I thought we started with O3 Pro. We talked about the Apple paper, and now we're on to Shobit's campaign for AI rights. But
Here we go, Hermione.
go on,
Hermione
Shobit.
Granger here. Go on, Shobit.
so here's my take on this, right? I recently we had Moderna combine the CHRO and CIO function into one. So one of my CHRO clients got spooked, and she and I were sketching up what a trusted employee is in a company today, human employee, and I was trying to extrapolate from there what a trusted AI employee would be. So if you offer all of a sudden when we're hiring people, newcomers in the company, fresh hires from the industry or interns, we do a really good job of carving out the right set of tasks that I can delegate to a individual intern or a new hire without having to give them step-by-step instructions and hand-holding them all the way through. We already have mechanisms of thinking about it in that way. But somehow, when we get to an AI model, and if it's performing at 95% accuracy, we're still not satisfied. Right? We, I think, have to do a better job of appreciating what are the strengths and weaknesses of a new hire and allocate them work accordingly. And the same thing should extrapolate over to an AI model as well. There will be a place to get a very high end PhD level O3 model pro. There'll be a lot of places where we need a much, much smaller model. I'm doing some multi-agent frameworks in production for some clients. I need the orchestration agent to have the logic and think through how do you go delegate this down to smaller tasks. Right now, anything less than 70 billion parameter model is not working out well for me. So I'm struggling with how do I influence the reasoning model to do things a certain way. And right now, the bigger models are just completely slamming this through. So we'll get to a point where smaller models in the enterprise environment, we would be able to influence the reasoning and make it work. There'll be much, much smaller models like interns, and we'll have a better appreciation for what accuracy and how should we measure the model end to end.
And yeah, I think these kind of discussions like are going to increasingly get asked, right? Is just like this kind of weird line between, well, what is this that the model is actually doing? But I think to your point, right? Like I think it's this battle between pragmatism and then kind of like having to know. And I feel like that's kind of like a classic theme in the AI space. All right, I'm going to move us on to our third segment. I think one of the things I keep looking for every time one of these AI headlines comes out is the fact that the transaction dollar amount is just getting bigger and bigger and bigger. And this week was no exception. A huge $15 billion transaction announced between Meta and Scale AI, which, if you're not aware, is one of the big players in the data annotation space. So this is a massive transaction. And I guess, Chris, maybe I'll throw it to you. I guess the question with always all of these is like $15 billion. So why is Meta so interested in this?
I think probably they want to try and get ahead in some way, shape, or form, right? So the reality is, I love the Llama models. I think Llama 4 is great, etc. But I think there's a little bit of frustration that they're not maybe ahead of Anthropic, they're not ahead of Google, and they're not ahead of OpenAI at the moment. However, with that being said, they are great models, and they're some of my sort of go-to models all of the time. So I think this is, let's put another bet in the ring there and run something else in parallel, and then hopefully get to where they want to go. And I think the reality is, this is being touted as a winner takes all market. I'm not convinced it is, but I think the reality is that you have to spend that type of money to be in that game. It is fierce competition. So if that means attracting new talent and bringing that in and being able to set up a lab focused on super intelligence, I don't think that's a bad idea, because there's probably two competing things also going on at the moment, which is they need to get AI into their products, they need to get AI out to their consumers, etc. And that's different from actually how do I set myself up for the future. So by actually splitting this up a little bit and saying, okay, you're going to be focused on super intelligence, and we're going to continue to get Llama out to folks and get it into our platform so people can use it and sort of gain productivity benefits, then you don't have sort of competing goals and intentions. And therefore, the folks can be focused on different things. One is going to be focused on the research element. One is going to be focused on the product. And so I don't think it's a bad thing.
Well, and on that, and I think Shobha, you want to jump in. I mean, I think what's curious about this transaction is in the past, some of the really big deals have been around like sort of technical leaders in the space, right? So, Noam Shazir, right? Big acquisition built around that, right? Like obviously the kind of like key leadership of OpenAI has been involved in all of these big deals. What's interesting about Wang is that he's not like necessarily like a noted machine learning, expert or pioneer. Shobha, I think that almost kind of suggests that there's like other things leading Meta to this acquisition. I don't know if you agree with that analysis.
So Meta is just trying to make sure that LlamaCon does not become a WWDC.
Uh-huh. Sure.
But the Alexander and Lucy co-founded Scale AI. Both of them are brilliant. Both of them the youngest billionaires. Like he's worth like 4 billion plus at this point. He's like 28 years old. Like what a phenomenal story. I would argue that he has done an exceptionally good job. He himself has been a math prodigy, coding genius, and whatnot. So I would say that he has had the street cred comes from a very talented family as well. So I think he has done the right way, and we've worked with Scale AI quite a bit. Phenomenal assets. They do a really good job at creating synthetic data. They've done a lot around how do you get this data ready for training these models. And there are very few competitors who can actually do what Scale AI is doing. There's like a dozen more people that we look at and work with, but Scale AI has definitely done a really really good job. And this is definitely an Acqui hire, right? There's no other way for you to get Alexander to come and join. And Meta has recently gone through a couple changes in their org structure and stuff like that in the machine learning and generative AI and AGI groups and stuff like that too. So clearly they usually do not hire high profile people in leadership roles. This is an exception, and it's a very senior role that they're bringing an external person for. It just, I think, doubles down on what Chris was saying in terms of where Meta is with respect to the market today with OpenAI. On one end, you have Apple saying that, hey, this is overhyped. On the other end, he's like, hey, we're already past singularity. So Meta is somewhere in the middle. He's saying, which side should I go? I'm going to go follow where the market is going, right? So I think there's a lot. The $15 billion, if you look at the overall capex that Meta has committed to spending this year, they're looking at about 60 billion-ish is what they're going to spend this year. They've been spending half of what AWS and Microsoft are spending in capex on this every year for the last 2 3 years, right? So this year, Meta is doubling down and catching up. Even if they spend about 60 $70 billion, this 15 billion will come from that particular portion. Companies are getting very very creative with how they're handling talent and IP and data. Scale AI, like, I think, is a really really good acquisition, or at least 49% acquisition for Meta as a company. They need it. We're still waiting for the behemoth, still waiting for a really good reasoning model from Meta. There's a long way they need to go, and they have to shake things up a bit.
Yeah, for sure. Kautar, final thoughts. If you had $15 billion, would you use it to recruit Alexander Wang to your company?
Well, maybe I might not be as bold as Meta, but overall, I think it's a strategic move. But this also what is showing. I think this is showing a growing trend. Infrastructure matters as much as models. Training, data, evaluation, human feedback, and I think this is where the AI wars are being fought right now. So, infrastructure playing the AI race is becoming very important. This investment, I think, highlights the broader industry trend where controlling the underlying data and the infrastructure for AI development is becoming as important as, if not even more important than just developing the new models. So I think Meta is really betting on securing its foundational AI supply chain with this acquisition, which I think is very strategic and it's the right move for them. So of course, I think they're betting a lot. I think they're saying also they want to secure this high quality data for AGI. And AGI, I think, is one of their big bets for the future. And I think this investment they're doing is kind of trying to secure for them that future.
Yeah, that's a great response, Kautar. I don't know if I would be as bold as Zuck to spend $15 billion. We'll keep an eye on how this deal goes and how this partnership evolves. As always, this was so good. Kautar, Shobit, Chris, thanks for joining us. And stay tuned for our next segment. We will have an interview with Oliver Dial, who I recorded an interview with earlier today, focusing on some recent announcements from IBM Quantum. So, as I promised at the very top, we wanted to make some time at the very end to talk about a super exciting announcement that's coming out of IBM on Quantum. And in some ways, we have, I think, the perfect person to talk about it. Oliver Dial is joining us on the show. He is the CTO of IBM Quantum. Thanks for taking some time today. Really appreciate it.
Absolutely no problem.
At MOE, we don't usually talk too much about quantum, but we keep an eye on it because our scope is just emergent technologies in general. And unfortunately, most of the airtime is always taken up by AI, but we always want to keep an eye on what's happening in quantum, in part because there's just really exciting things happening. And so, Olive, really excited to have you on the show. The thing I always have with quantum is that people are always like, it's never going to happen. People have been talking about quantum forever. And I think what's really kind of interesting is I always push back and I'm kind of like, look, in the last 24 months, there have been some really kind of major leaps in quantum that kind of make it feel like, even though everybody's complaining about how long it's taking, it might actually finally be around the corner. And so I think I wanted to bring you on the show to talk first about kind of like the announcement that you guys have that came out today from IBM on the idea of sort of fault tolerant quantum computing. And so I guess maybe let's just start with the problem. I guess, Oliver, I'm curious if you can kind of walk us through why has basically like fault prominence or like fault frequency been such a big problem for getting quantum to actually work practically?
Yeah, well, at the end of the day, you're trying to do computation with some of the most sensitive systems anyone's ever made in the world. You're trying to manipulate single quantum states and use them to store information and compute. And so the error rates that we have with today's hardware are orders of magnitude larger than what you would have on a classical computer, many orders of magnitude. In fact, for our 2-qubit gates, which is what we usually talk about when we talk about error rates, our current failure rate is about 1 in 1,000. And so imagine trying to do computation where the computer one time in 1,000, it makes a mistake.
Yeah,
Like
and I think like
that's
those errors are caused by just like it's like too close to an electrical field or something, right? Like it could be anything.
So the biggest one for our qubits is we actually store the 1 or the 0 in a single microwave photon. And so anything that can absorb microwave energy can suck that 1 away and turn it into a 0.
Which is
And
kind of like everything, right? Like
everything,
yeah.
everything on the planet. The worst thing for us are surfaces, because anywhere where there's a surface, there's a place where you can have like a thin layer of oxide, you can have contaminants, you can have all kinds of things that will absorb microwave energy. So you're trying to do computation with this fantastically high error rate. And the really amazing thing to me is even today, despite that high error rate, we're already doing computations that a classical computer can't run, right? That's what we talk about for the era of utility. And the reason is we have a lot of ways that we can sort of statistically remove the impact of those errors. So today we play a game where we run a circuit, we run a quantum computation many, many times. We statistically remove the errors to get an accurate answer out. And using that, we're starting to be able to tackle some really interesting problems in chemistry and optimization and material science. And we
You're
think
saying
that'll
like
get us.
quantum's like already here is kind of what you're saying.
We're saying you're probably going to show quantum advantage, so doing something better, faster, cheaper than a classical computer by 2026. And actually, I think it's going to be even sooner than that. And you were talking about this cadence of news releases. I mean, that is going to be such an all boats rise moment, because that's going to be saying, okay, wait, this isn't something that's going to be next month or next year. This is actually really happening today, now. But the big thing with all these techniques we use today is they have an overhead that scales exponentially with the size of the problem. And so it's a little bit of in the long term, a losing proposition. We have this computer that's exponentially faster for some jobs, but we've added an exponential overhead. And so, it's a real
Because
horse
like I think
race.
like is it right to say like kind of almost like the bottleneck is like computation, right? Like you're basically
Mhm,
saying like we've got this noisy process and we kind of denoise it
mhm.
using computation, but it just kind of can't scale the way we want it to.
Exactly. So when we talk about fault tolerance, we bring in another set of tricks, and it's error correction. Like if you're doing communication between a classical computer, you might include parity bits so that you can detect if the data got through correctly and retransmit it. We can pull the same kinds of tricks with a quantum computer. That these error correcting codes are really nice because they, instead of correcting the errors after the computation is done, which is where that exponential scaling came from, you're actually correcting the errors on the fly as you do the computation. And so the overhead is no longer exponential, right? So if you can crack error correction in a way that lets you get to this fault tolerant regime, then now you can really do any computation you want. The cost of building the computer is logarithmic, sort of, in how large you want the circuit to be. Now, not all the error correcting codes that we can talk about are the same. A lot of people have talked about using something called the surface code, which is a really neat code. You've got to remember, at the end of the day, these qubits aren't, virtual objects. They are physical things on a chip. And there's actually little superconducting wires connecting these together. Like, when you actually look at these devices, they're really pretty looking. So those superconducting wires connecting them together, if you're doing an error-corrected chip, you really want them to exactly match the parity checks that you want to be able to run, because that means you can run those parity checks really efficiently without introducing additional errors. For the surface code, the layout that you want for the qubits looks like a checkerboard. The qubits are on their square lattice and nearest neighbor connections. So that's really neat. Like as a semiconductor manufacturing person, you can kind of look at this, you could say, yes, I can see how to build this. It's not too bad. The problem with the surface code is you're talking thousands or tens of thousands of physical qubits per logical qubit. And so although it's easy looking, it's not practical. It's too expensive. It's too large. To put that in perspective, the largest devices that we've ever made are about 1,000 qubits.
Oh,
So,
okay.
it,
So
yeah, so,
you're
and
kind of priced out of doing this very quickly.
exactly. And those are also, by the way, the largest devices anyone has ever made. So,
Sure, right.
And so part of this announcement is we have this new code that we're calling the gross code. And we're calling that not because it's disgusting, but because dozens keep on showing up whenever you talk about it, and a dozen is called a gross. So the gross code breaks the rule that we had in the surface code. You can no longer lay the qubits out in a checkerboard. In fact, each qubit, in addition to that checkerboard, has two long-range connections that go to other qubits that are far, far away on the device. Think of it as like a highway overpass across the chip. And what those let us do is create a code that is much more efficient. With the gross code, with 300 physical qubits, we can encode 12 logical qubits. So the qubits come in 12 packs, which is kind of neat. But it's an order of magnitude fewer qubits than you need for the surface code to build devices like this.
That's fascinating because I think, almost like the way you described the problem initially, I guess, again, my layman's view is like, well, just try to shield it so you don't get so much noise. And kind of what you're saying is like the solution is a physical solution, but it's like for the purposes of making the kind of computation process like just much more efficient. But in some ways, you're not trying to deal with the fundamental problem that like these are really delicate systems that like are subject to all sorts of kind of like interference from the environment, kind of.
I mean, we do want to solve the fundamental problems too, as well as we can. That what these error correcting codes do is they sort of exponentiate your error rate. And so the gross code, we call it a distance 10 code. Basically, the error rate goes like your physical error rate to the fifth power. And that's really neat in the sense that if we make our physical error rate 10 times smaller, the logical error rate will get 100,000 times lower. Right? You get this enormous lever arm on that physical error rate. And so actually your incentive to continue to make the underlying physical hardware better is still there. It's, if anything, even stronger. But there are fundamental limits that we think are going to be really hard to exceed. You're never going to see a physical error rate of 10 to the minus 10 coming out of these systems. There's just too many sources of error.
Well, and so I think one way of thinking about this is I think a little bit about like we've got, existing computers, traditional computers, if you will, that can solve like kind of a certain landscape of problems. And then I think what you have is quantum now kind of like catching up, right? Like, you look across this landscape and more areas of the map are filled in by like, oh yeah, quantum could do that. Or like, and even it's like new places of the map, right? Like, oh, you can never solve that problem with traditional computing. Quantum can do that now. Do you want to give our listeners a little bit of an intuition for like, with this kind of efficiency gain, I assume like you all have certain problems in mind where you're like, oh, suddenly we could start to crack ABC problems. And I think maybe it makes it a little more tangible to, I think, talk a little bit about like where this goes, right? Suddenly you can approach someone and say, hey, maybe quantum is an application for what you're doing. I'm
Well,
curious what you think those are.
so today we're just barely beginning to be able to do sort of small chemistry problems, like a couple of atoms, a key part in a molecule in a way that's compelling. With these fault-tolerant computers, really complex chemistry problems in catalysis and organic chemistry become possible, as well as a lot of really interesting problems in material science, studying superconductivity, studying um, exotic states of matter become possible. One of the original motivations for quantum computers, you've got to remember, was ultimately simulating quantum systems. But I think the thing that excites most of our clients the most is optimization. And that's a place where having a wider logical register, more qubits that work better is just a huge benefit. Because of course, optimization problems, nobody really cares if you can solve a small optimization problem, right? Because in practice, they're not small.
Like, yeah, exactly.
And so, even as we're working on better algorithms so that we can solve these problems on near-term hardware, it's this fault-tolerant hardware that is really going to begin to unlock this space. And so when we're talking to financial institutions, when we're talking to logistics companies, that's really where we get a lot of interest.
Yeah, I think that's like one of the wonderful things about the kind of like current generation of all these like kind of emerging technologies. Because I joke about it all the time in the AI space, where you're like, you've built a machine intelligence, right? And then you're like, actually, the primary application is that we use it to like kind of like optimize like customer service. And I guess in some ways, like quantum almost has like a very similar quality, right? Which is like you're literally playing with like the fundamental building blocks of reality. And then it's like, we got to solve the traveling salesman problem, right? It's like kind of where you end up.
I'm not sure the traveling salesman problem has that much money behind it. They're really good
Yeah, sure.
approximate answers there.
Yeah, that's right.
But
Well, that's great. I guess maybe just the last question is I'm curious about now that you've kind of worked on this, like what's next? Like, what do you think is the next big challenge that the community is focusing on? Maybe give us a flavor for like what we might expect in the next, 6 to 12 months.
so I think, well, first big one is quantum advantage. We are going to see it. And like I said, it's just going to be the gunshot that gets heard around the world on quantum. The other one is, now that we've announced this roadmap to fault tolerance, I think we're going to start to see a lot of other competitors in the field updating their roadmaps to use some of the same ideas. And so we're really going to begin a second stage, this race to fault tolerant.
It's like game
quantum
on,
computers.
basically, for you
It's
guys.
game on. And remember, we have a plan. It's really neat that in principle, we have solutions to all the problems that you need to build a fault tolerant quantum computer. To the extent that we're actually starting to build a data center in Poughkeepsie, New York to house these things. Like, that's where we are in the planning year. But every stage of that can get better, right? We have a bare minimum. We are continuing to do research. We expect every aspect of our plan to still continue to improve and for these machines to only get more capable than what we're anticipating today.
I think maybe just the one thing, maybe to kind of end where we started, is, I've been hearing a lot from quantum people about like how this is very soon and going to come in the next 12 months. And this is going to be a shot heard around the world. I don't want to be too mean, but kind of like, why should we believe you guys that this time is different, right? Like, what about your roadmap makes it like an actual practical thing?
Well, if you think about the way we build really complicated machines, the key is to be able to build them out of an individually testable and composable unit cell. That if we needed to build, Blue Jay is going to be about 100,000 physical qubits. If I needed to build you a 100,000 physical qubit chip, we would need aliens to come down to Earth and give us that technology. But the great thing about the gross code is the module size is actually pretty small. Once we've added all the extra qubits we need for computation, we need for communication, we can build a module of about 500 qubits. And that module we can then step and repeat and connect together to build this system as a whole. And so the great thing about this design is that we don't need to build a 100,000 qubit system. We need to build a 500 qubit system. We need to be able to manufacture it. We need to be able to test it. And we need to be able to connect a lot of those together. And so it's really that modularity that is bringing this into reach. And the fact that the module size is no bigger than what we built in the past, right? We built Condor. We have built a 1,000 qubit device that was only a little bit less complex than what we need to build to make this code happen. And that's why we're saying it's practical.
That's awesome. Well, great. I'm really looking forward to having you back on the show, Oliver. And thanks for taking the time today.
No problem at all. Thank you.
Thanks all you listeners for joining us. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we will see you next week on Mixture of Experts.